Okay, we are solving the problem 1415, the kth lexicographical string of all happy strings of length n. So a happy string is one that consists only letters A, B, C, and the adjacent letters are not equal to each other. So s of I is not equal to s of I plus 1. And we have been given two integers n and k, and consider a list of all happy strings of length n sorted in the lexicographical order. And we have to return the kth string of this list or return an empty list if there are less than k happy strings of length n. So if you analyze the question a bit from the examples, you can figure out that there is no need to apply direct backtracking on the entire list. I mean, there's no need to generate a list for this question, not at least the entire list. uh, you can probably get away with uh, generating 1/3 of the list, not even 1/3. I mean, you can get away with quite a less number of formation of the string. So how you do this is, first of all, you figure out the total number of you know total number of strings that are gonna be for a length n. So from the examples, so if n is equal to 1, there can be three strings a, b, c. If n is equal to 3, there can be 12 strings. So this 12 strings are going to be divided equally among a, b, c. So for each character you're going to have 12 by 3, so that is 4 strings. So that is a good hint to figure out that, okay, so I don't need to figure out the entire sorted list, but maybe if I can find the total number of strings, maybe I can figure out a way to reduce our computations. So for this example, for each character there are gonna be 12 divided by 3 uh, strings, so that is 4 strings. And you have been given a task to find k, the string at k equal to 9. So k equal to 9, that means it's gonna fall somewhere in this uh, sub list, right? Because k starts from 1, because the list starts from 1. From 1 to 8 are gonna be these strings, and 9, 10, 11, 12 are gonna be this sub list. So that kind of gives you the first character of the string. So as we know that it's gonna fall in this list, in this sublist, you're gonna say that, okay, the first character is C. So in a similar fashion, you can figure out, okay, in this sublist, what is the index at k equal to 9. So for k equal to 9, it's gonna be the first index, the 0th index, because this is 9, this is 10, this is 11, and this is 12. And the constraints are such that if you find the first character, you can pretty much apply a normal backtracking to generate the ninth string. So we can get started with this. uh, just a minute. Okay, yeah. So first of all, for k equal to, so they've given this condition that you have to return an empty string if there are less than k strings, so we can figure that out first. For now, we can write total is 3 if n equal to 1, else it's 3 times 2 to the power n minus 1. So you can try this yourself and figure it out. And if k is greater than total, you can just return a null string. Now going on to finding the division and the remainder. So first of all, for each portion, for each character ABC, the total of each character is gonna be total mod 3, total divided by 3. The division at which the character is gonna lie is gonna be k minus 1 uh, floor division of total each. So we take k minus 1 because well, this is easier to code up. So this in this way, if division is 0, you're gonna start with a. If division is 1, you're gonna start with b, and if it's 2, you're gonna start with c. Similarly, this is gonna be k minus 1 mod total each. So here the indices are gonna start from 0 to 3 for for this example. uh, and we can declare a result, and we can declare a count. For we can initialize it to -1, because um, in the code, this count is going to be a non-local variable in the recursion, and it's going to increment every time we generate a valid string. So that way we can keep a track of where we are, and then we can find the rem variable. So let's recur. We can pass a string here, and non-local variables are res and count. So if the length of string is equal to n, so if the string is completed, you can increment the count. So count is initially -1. So when you find the first string, the count is going to be 0, which is essentially equal to the index here. So for this sublist, the index 0 is this, right? So and if count is equal to rep, we can just say result is equal to string, and we can return true. So that way we will get to know we've already found a string. And this is the base case. So after that, we have to iterate from these characters a, b, and c. So if the previous character, if ch is not the, I mean, if it is the previous character, we can just skip it. If it's not the previous character, we have to recur. So if recur of st plus ch. So we're gonna say if this recursion returns true, we can just return true. Or else, we're gonna return false. And we can also return false here. If the count is not equal to rem, or if it's like less than rem, we want to return false. This should be the end of the recursion portion, and all that's left is the starting character. So if start, let's declare start as a null string, and if the division is equal to 0, start is gonna be a. And if it's equal to 1, start is gonna be b, else it's gonna be c. And then we can run the recursion on the start variable, on the start string, and then we can return the result. So let's give it a try. Okay, let's try to submit it. There you go. This should be, yeah, exponential 3 to the power n times solution, which I think is the most optimal one we have. Yeah, I mean, yeah, not really sure, but yeah, there you go. See you tomorrow.